Tony Tang, the man of the hour. You're going to be grilled today, mate. You got a couple of stellar hosts here who are going to question the shit out of you.
Bring it on.
Beautiful.
At the time, we had the largest gold operation in the Southern Hemisphere. We were treating 35 million tonnes of gold and copper minerals, and then we're producing roughly about 1 million ounces of gold. And I never forget every moment, every single time I'm doing engineering today, it flashback everything that implanting that knowledge to me at a very young age. I remember he's a big influence of me.
That's awesome.
She has her own digital twin. She has her virtual AI of her.
Yeah.
She's a professor at Murdoch University and also running a law. A few years ago when BHP started producing nickel sulfate to supply to Tesla and Toyota and other battery manufacturing. The future is there, but we still need more people going through it.
Yeah.
Yep.
To have this battery plant in Kwinana or in Kalgoorlie or anywhere in Australia.
Welcome back to another episode of The Gold Room. Thanks for tuning in. Today, I'm lucky enough, once again, to be sitting down with Ditto. Thanks for coming back, bro. Much appreciated.
Love being here.
Tony Tang, the man of the hour. You're going to be grilled today, mate. You got a couple of stellar hosts here who are going to question the shit out of you.
Bring it on.
Beautiful. Hey, right, so mate, we always start with the life and the times. So give us a good rundown of who you are and where you came from and plans for the future.
Thank you, Josh and Andrew. So Tony Tang, I migrated here from Vietnam. My parents migrated from China to Vietnam, so I was born in Vietnam. I came here in 1984 with my mom and dad and other sibling. A family of 14. I'm number 12.
Jeez.
What?
Yes, and I study at when I came here. I studied at Perth Modern Senior High. Do my English there. Then I study my year 11, year 12 at Manly Senior High, and I got to university, and I study multidiscipline science initially at Curtin University, and got into chemical engineering, and later on I did my extractive metallurgy at School of Mine in Kalgoorlie. During that time, I worked in various places in commercial laboratory and then research laboratory. So when I graduated, I immediately got a job right away. It's pretty much the same as current student. They do the vacation work, and eventually they end up a job with a company that really appreciate the effort. So I got into piloting work for the second generation high pressure acid leaching for nickel laterite. That was giving me a lot of opportunities to see things from bench scale to medium size, sort of semi-continuous work, and into almost like a replica of commercial scale, but in a smaller scale set. And from there, I built my knowledge and experience of how to take things from concept all the way to production continuously. And I was very fortunate to be offered a job in the nickel operation. Back then it was Kalgoorlie. There was 2 operations there, and as well as the one that Andrew Forrest started at Maramaran. And so I went there and joined there. So during my time up there was a final construction phase. And then I get into work in the lab and then work with the other engineers and commissioning a lot of equipment, set up laboratory, set up instrumentation in the plant.
Wow.
So I was working there for nearly 10 years. During that time...
What year was that? What year was it?
So 1998, that's when I was on site as an employee, and then worked all the way to 2007. And then I left Maramaran and then joined an engineering house in Perth called Aker Caverna. Then a few years later, they changed their name to Aker Solution, and then Aker Solution, they changed to Jacob Engineering. So during that period of time, it was amazing. I get to expose different commodity projects, and I work on Boddington Gold Mine expansion with Aker. We got Clough and we got Robert Murray's group, and the project, we have engineering team work in South America, in Argentina, in Chile, in Santiago. So we worked cross international, and that was 2007, and it was really good. And at the same time, when you're engineering, how you're not just doing one job, you're doing multiple jobs. So I was working with BHP on the project, around the world on nickel. One of the big projects that now the Chinese doing is from Indonesia, and at the time the name of the project was the Pearl Project. Really? for BHP. And also at the same time, I was involved with Olympic Dam, doing the big study of the 10 million ton and 30 million ton as well.
Wow.
And then working with, a lot of uranium projects study at the time. We got Yaliri in WA and then uranium in South Africa, like Zambia, the Rossing South, and Namibia location. And then that rare earth kicking in late 2008, 2009, the rare earth kicking in. So I got involved with Arafura, with Linus, and a lot of rare earth and some of the rare earth project in America and in Canada. So I get to work with that as well. So it's a very fast phase when you work in the engineering house. You get to get exposed when you understand from doing laboratory work, how to design the test work, to collect the data, to take that data to the engineering, and from that data you develop the flow sheet, and then from that flow sheet you start working on how you're going to optimize it, how you're going to create the flow sheet that suitable for that particular mineral that you're exploring. And that was a very rewarding. And then I went down to Boddington in 2008, also involved similar what I did in Marmon, involved with the part of completion team. I was working on a process control system, and basically that's the only plant that has the most automation at the time for the gold plant. So I had a really strong team. We almost can control the entire operation, apply a lot of new technology, and it was great. And so 2009, we complete the project, fully tested, hand over to client, and the ramping up and the commissioning was pretty much unheard of how quickly we meet the nameplate at Boddington. So it was, at the time, we had the largest gold operation in the Southern Hemisphere. We were treating 35 million ton of gold and copper minerals, and then we're producing roughly about 1 million ounce of gold. Right, and lots of copper concentrate was shipping out, and that was a really successful project. When I involved with the study, the gold price was only $385 per ounce.
It's a far cry from today,
and then,
isn't it?
Yeah. And then when we finished and commissioning and put the gold, the ore through the system, the gold price in 2010 is roughly about $1,000 to $1,100 per ounce. Even though the project was delayed, but the benefit that the plant that we built, I was so proud of it. So we put into an application into recognition with Engineering Australia, and we awarded the project in 2010 for the Excellency Award from Engineering Australia. So it was a big highlight for me. Then I get to do a lot of other projects like Arafura, go from very concept in 2009, 2010, doing desktop study. The client gave me only 80 hours to do process modeling, end up giving me the whole project, work together with another engineering house. So we took that chemical recycling plant, in that plant you're producing a lot of waste material, and we look into how to regenerate hydrochloric acid. So I did the modeling, did the study, and it was economic.
How long did it take? How long did it take to do the study for that?
So the 80 hours, that was the budget I have. So it took me roughly about a month to finish that study. Wow. The client was very happy with it. It led that to the next 300 hours is to do the desktop study. And that desktop study is basically looking into different flow sheets and doing the economic, a very high-level economic and SWOT analysis. And then after that, we got the fund from the investors for about $9 million.
Awesome.
And then the project start from there. We designed the plant and built it in WA, and we're producing roughly about 100 liters per hour of hydrochloric acid from calcium chloride, which is the waste product. And then for that, we can generate that hydrochloric acid back to leaching the rare earth. So that was a really good, and it's done in WA at the lab called AOS in Balcata. So we built the whole entire pilot plant to treat waste product into regenerate hydrochloric acid.
Sustainability.
And then the other beautiful thing about the other byproduct is gypsum, and we're producing 3 grades of gypsum. So the first grade is normal for your chipboard, but the highest grade is the one that you're using to produce the binder, the glue. So when you keep gypsum board, you still have to glue it. And it has different property and different particle size and formation. And that was very important. So the company in US, Knuff, is the one that produced. If you go to Bunnings and so on, you look at the glue joint, the gypsum Knuff, they're specific specifications. So we also produce that.
Wow.
And then the second product is also a high quality gypsum, but for non-flammable. So when you have a high-rise building and you want to have a non-flammable building material board, and you create that material at the same time as well. It was really cool and very fun.
I only thought gypsum was for gibboard. I didn't realise it was used in other products.
Yeah, so basically they form different hydration level and different particle structures. And if you get into the proper structure, it becomes very stable and very strong. So standard gypsum is they hydrate and dehydrating through the moisture absorption and desorption to hot and heat. The other one, they don't affect by it, and therefore that's why they're good for the glue. And also they're also good for the fire retard. So that's why when you buy the gypsum, you got the one that's not fire retard, and you got the fire retard, and they're different grade. So we're actually able to produce and put in a pilot scale, and our product is sent to Knuff and others gypsum producer to validate it, and that was back in 2009.
All from a waste product. That's really awesome.
Yes.
Tony, you've covered a fair bit of ground there. So is there anything like in terms of a key experience that you think's highlighted maybe where your career direction went or has defined you?
For me, it's all come from my dad. My dad's he's an entrepreneur and self-taught mechanical engineer, and then he get recognized for his creativity and inventions. So when I grew up with him, very young age, he always took me with him, and we built the first sugar refinery in Vietnam, from sugar cane all the way to the white sugar that you put on serving table. And he walked through with me the whole journey from sugar cane plantation, harvesting, juicing, concentrating, refining. But that's part of it, is how he designed the equipment. Even you plowing the soil to make it rich so you can plant the sugar cane. How you harvesting it, how you juice it, how you concentrate it, and he came up with all these innovative equipment himself, and he built it in house. And that was how I knew how to think at a very young age, critical how to think of how to look into how to innovate and create. It was amazing. As a child, I was handheld by my dad. And I never forget every moment, every single time I'm doing engineering today, it flashback everything that implanting that knowledge to me at a very young age. I remember he's a big influence of me.
That's awesome.
And then he went on and doing so many other food industry, like we treating rice, how we harvesting the rice, plantation the rice and the crop, and how we going to remove that husk, the shell, and effectively, and then we do with the corn, the peas, the bean, how we producing MSG in Vietnam, how we producing soft drink in Vietnam, and all this coming up by him, understand he walked into the factory, learning the concept, come back, innovated. I remember one of our plant, we only have 2 diesel machine running, and we had generator and run the entire factory.
Wow.
Right.
What I love about this story is like you're now linking 2 different industries. You've got the agricultural side and you've got the mining side, and just you can see the synergies exist, right?
Absolutely.
Yeah.
But the thing that my dad...
It's innovation and innovation from trailblazers in their own industry, right?
Yes, yes. So he was not afraid. And we have our own fabrication, and we have our own battery recycling in Vietnam because it was lead acid. And, when it gets to the point that it's no longer holding the power, he watched how other people produce it, and we have our own battery storing the battery when the generator is out. We have banks of battery, and this we're talking back in 1970s. We're not talking about 1980. In 1970, and they have banks of lead batteries, right? And when they no longer serve the service, he took it out and put it blank, resurface it, and then just exactly we do. And then even metal, when we off cutting them, we have a workshop cutting them. He sort them out, remelt them, and reform them, and then back into the factory. So this practice has been within my dad. He's not just talk; he actually did it. And I grew up with it. I grew up with that. And we got our machinery, how we build a bolt and nuts. And, all these little dial measuring, and he does it. And I just stood next to him.
That's amazing.
And he just explained how he does it. He used to draw engineering, what he wants to build and design with pencil and paper. And
no CAD programs back then, right?
No, and he shaded them. He made looks like so real, and he never actually trained at university. He just had that creativity. So that's where my creativity coming from is actually purely from that.
Awesome, mate. You've been in the industry for such a long time. Tell us about some significant challenges that you've seen or come up against.
The challenges we have today is we start seeing the level of skill set requirement for our industry is dropping significantly, and that's why we see a lot of migration of skill came to Australia. Although they are great, but we have certain standard, and that also take times for those skilled people to understand our standard and practices.
What's driving that, do you think, Tony?
I think because the communication hasn't been going very to the right level, and we're talking about if we really want the children to go into this industry, we have to involve with them early on. Good old days, we tend to wait until year 11, year 12, or year 10 when career 9, or then we start communicate to them.
What do you want to be when you're older?
That's right.
It's too late.
That's right. And because of that, and we now have such a high demand of workers, and we're prepared to take people from TAFE, we take people with limited knowledge and operating on site, and then eventually work their way university of hard work, rather just like my dad. And because of that, your level of knowledge, the foundation, not there. And that's the challenge. Is we need to bring that training methodology back to early stage, so the children they understand that we in Western Australia endowed with rich minerals. At the moment, we are not take the best advantage of what we have. We tend to ship out the ore or the concentrate. And then that's a small value. And when you get the final product, which is about 50 to 1,000 times of the value, it's not sustainable. So for me to see the challenge right now is for us is to be able to have enough technical people in order the industry of downstream processing to feel that they comfortable, the risk is no longer there. Because when you start a business, you can do all the engineering, all the study, but at your final investment decision, say, have I got the people? Have we got the people to run this $1 billion, $2 billion operation? Have they got the right skill set? And at the moment, we have very limited numbers in Australia, and that's the reason why we encouraging foreign professional and expert come to Australia. However, that still requires transition of understand our way of doing things. Safety is our number one priority. It's no but or if, but we need to make sure they understand the way we arranging our equipment, the way we operate our process, and the way we treat our people is quite different than other countries. We put people first, their health first, their family, their community first. And this is the difference when you migrate a professional from another country. They might not have the same, they're similar but not the same intensity that we have. We only a population of 26 million people in Australia. We take a lot of care to protect our citizens. And people come from other countries, they might have hundreds of millions up to billions of people. They have different growing up environment, and they're not been exposed to our values and why our countries spend so much effort to protect the people we have.
Now, I'll just go back to where you said the secondary industry, because I think that's a really important point. Like, Australia needs to generate a second industry, and one of the big challenges we face is the cost of labour, and the other countries in the world, they don't really have that same problem. But there's technology that's coming in, and there's reducing headcount requirements, and I guess they're starting to impact project economics. I think there's a huge potential for where we might be going into the future, right?
Absolutely. And last night we have an event in Perth talking about the AI and the machine learning and the robotic. How did it help to filling the gap of labor shortage and skill set shortage? However, we still need a lot of people who knows how to set these instrument or set up the parameters and the boundary of the AI and the robots. If we don't understand, it takes even more harm than benefit. It takes time to learn, and it takes time to train the robot to do exactly the machine to do what you want them to do. And if we haven't got the people to learn how to troubleshooting, then we rely on overseas to coming over. And each time we do that, we're losing. So we still have to bring that all the way to vocational training, TAFE training, university training, because without them understand, we might have one or two operators or technicians learn how to run this, but what happens if that person is no longer there? Have we got a replacement? These are the things that we encountering in every operation, doesn't matter if it's mining, into manufacturing, the same thing. We thought that we have these people. Another company opened their operation, and they approach your staff and pay 25% more, and that staff is not being looked after. They move. And then suddenly this company has been running really well, and they're struggling to get things the same. So that's why we need to have a very strong pipeline backing up our incoming skill set people. We can't just rely on one or two.
And who do you think owns that? Is it industry alone, or is it going to be the university, the collaboration? Is government involved? Like, where does it sit?
So for me, it's about communication. You communicate to the general public, because it's not about who's responsible. It's about general public who has the power to empowering their children where their career path.
That responsibility falls on everybody.
Absolutely.
From it starts with the parents. It starts at home.
Yes.
And then obviously at school, the school teachers.
Yes.
Maybe they need to have, maybe at primary schools, they should be looking at having, career counsellors, not just at that high school level. Maybe they need to be saying, like looking at skills or attributes that a young child has and says, well, look, Jazz Diab a few months ago said, maybe those young girls that are interested in hair and makeup or beauty products, maybe they're upcoming scientists, leading in a field. You just don't know. But if they're interested, because it's mixing chemicals together. So if you're able at a young age to say, hey, listen, this is how this works, you enjoy putting makeup on. Maybe that's an avenue.
Yeah, you can't be what you can't see, right?
That's exactly right. Yeah,
and it's all about education material, and also if they grow up in a very comfortable environment and not knowing, and that's why we need to bring these sort of global experience how other countries have their children heading to the right direction or the direction that the country need. How do they do it? That's what collaboration is about. It's about learning, and it's about exposure, and it's about, if you don't understand the consequence of not take action early, and this is what happened. And you can see now we do not have a lot of manufacturing in Australia. We do not have a lot of planning and incoming manufacturing.
Can we bring that back? Do you honestly believe with the wages that we pay, do you honestly believe that we can bring manufacturing back to Australia?
Absolutely. Based on what Andrew just saying early on, it's quite important.
It's important.
It's
But
important.
we've given it all away. How do we claw it back?
And it's all come down to training, because if you want to implementing robotic and machinery is fully automated, you still need people who know how to run it and how to continuous improvement. We need to manage that continuous improvement, because the technology is evolving, and you still need people to understand how to going in and make changes and maximize the performance, and how you update the software, like your phone, right? Like your car. If you don't update the software, the car won't perform the same. And some of the app will not work if you don't update your operating system. It's exactly the same as robots, right?
Yep.
And then learn how to maintain it, and learn how to servicing it. And this is the skill set we need. So and then eventually that will help understand how the engineer from university, they look at this and they say, okay, this is version 8, just like iPhone 1, iPhone 2. We can changing that robots into more effective and more robust, and do multitask rather than just one task. And that's what we get involved, the university and people who study mechatronic involved. This robot is working great, but now we want to do extra tasks, because the AI calculation saying the efficiency operation of this robot arm is only about 75%. You still got 25%. What that 25% task that can be done? For example, if we turn on the screw, this screw can go a certain amount of speed, right? And then you can actually improve the position and the speed of it. You can do extra production, and that's why you push the production. But without the engineer understand what all the part component made into that robot arms, what is the limitation, the specification before you improving it. And this thing need to be trained. You can't just go and say, I'm driving my M3 BMW and I want to perform like an F1. You can't. And that's exactly what we need. We need people to be trained at university.
So at the Oz IMM conference, the AI and technology evening, I heard that the Chinese are now teaching their children from the age of 4, and the Americans have just signed a document to say that they're putting AI and technology into schools for 6-year-olds and up. How amazing is that? What do you think that we're doing? This isn't even a question. This is just...
For me, it's very important. Like that's where the children get their mental focus, and they become second nature. Because once their brains is already wired that way, they live in that environment. Their thinking is always ahead of AI. Because human brain work much faster, and you can't wait until someone at our age to start. AI already beat us because we haven't. So the foundation is coming from the children the moment they're operating it, and how they changing the they need to train the AI to keep what they want, and that is from going in and changing the parameters. A lot of adults is struggling, and the children at that age, you can give an iPad to a child at 4 years old now. Within hours, they know how to operating it. But if we don't let them expose AI, and AI going so fast, these need to be following in parallel. And that's why the earlier the age, the better.
But there's obviously other technologies coming out as well. So how are you keeping on top of the technologies?
And that's, again, exposure and having people who guide, people who put a lot of effort and guide. And this is now probably responsibility to the policymakers, the governance side of things, is allowing what should be available for future training. There are so many versions of AI platform available. There are some that just get information and they take it away. Some actually there to testing out where we're going. So this is about security and it's about proprietary knowledge. And AI is a beautiful platform for everything, but it needs to be trained. It needs to tell, you can only using this data set, this information, because all of the other data maybe sound similar, but they're not relevant. So you don't get the answer you needed. But then that's how we have the people who understand how to guide AI, training AI. If you have this question falling in this category, these are the set of data you use. You don't using a generic data. So it's become more, what you call it, the relationship of the information is relevant. If you have the information so broad, it becomes very generic, and therefore you don't get specific result that you needed.
Do you think that young kids at school, and I know even at university, there'd be kids going in to do an accounting degree, there'd be kids going in to do a law degree, and I can only imagine that there'd be some professors or tutors there that would say you need to be learning AI, and after a week of learning and working with and looking at some of the new technologies that are out there, do you think that some of them would be scared about the future of using AI and that use of technology? Are they going to be sitting back going, will I have a job? How do people get past that? You know, I know lots of people know that you need a person behind the AI. It's not just free thinking. It needs data packets. But still, anyone new to using AI, and that's why I guess we need to get young kids using it right now, because don't be scared of it. Embrace it, because you still need the human behind it to be able to drive it forward.
And that's a very good question, Josh. Curtin University, where I'm currently employed as a professor there, we have a team now at Curtin. It's basically saying, what is the community, the gap, knowledge, and the fear, and the university? And we need to identify those gaps. We do the strength, the weakness, the threat, and the opportunities with these. And so we, in the coming days and months, you will see Curtin University that communicate with the public, the general public and professional. And I'm one of the team that doing that. For accounting and law, it sounds scary at first because people do not understand what it can or cannot do. So that's why it takes people who more recent graduate law accountant who has been try and play with this platform and validating. The key word here is validating and relevance. If you don't have these people who very, I would say, comfortable using any platform and test them out and challenging it, because every platform has flaws. And one of the things we learned from last night events at All Startup AM was, how do you question AI where your data came from? Who created? What version are you?
Well, now with ChatGPT, there's if you pay for it, which I do, there's a deep research function. And I don't know if you've used it. There's a deep research function. If you click that, and it will take, usually it takes 5 seconds to give you information, a small data packet. It will go away in anywhere between 5 to 8 minutes, and then it will also give you all the references along. It's amazing. So amazing.
And that's important. Is
you still got to read through it.
Absolutely.
You can't just use AI and then be like, oh, that's the answer. You've still got to read through that information and then fact check it. You know, like.
And one of our panelists last night, her name is Shelley Jane Price. She has her own digital twin. She has her virtual AI of her.
Yeah.
She's a professor at Murdoch University and also running a law consultancy work. And with her student has certain query, they actually can see her digital twin And that's amazing.
24 hours a day, 7 days a week, they can ask her questions.
And how she trained her virtual herself. And one of the things he said, the first thing is be polite and be nice. So AI will always going to be open there, how they communicate to the student. Even the student asking some irrelevant or frustrating question, the AI replicate her her personality is to be nice to the student, and then get the student involved, and then you reply the question the way she would have answered if she's present. And that's the important thing. AI doesn't do that. So the personality that you put in there, she had to train that software, that her digital twin, this is how I behave. The information you supply, but this is the conduit, the medium that you're going to be put through. You cannot go outside that. And that, the effort that Shelley Jane did, and that's what I say, even AI is available, you still have to train it.
I love that the university is looking at this type of thing. But bringing it back to the mining industry, like what do you think the biggest challenges are from a university's point of view?
Believe me, I work with people from BHP and Rio Tinto and Fortescue. They are doing it. However, they are doing it based on the people there. But in order for evolving and embracing and adopting this technology, they need more people who ready and knowing, and that's why where university is filling in this gap, and that's why the next program we run at Curtin and other universities doing the same is to find you are doing this now, but what you're seeing is your gaps, right? And if your gaps is require us to take over that gaps, is start training the student to look into this. So basically, you work in concurrently rather than in parallel. So they identify this is what we can do, what we employ can do, and this is something that we would like university to be start training the student, start looking into it, and therefore by the time they graduated, we have a pipeline of specialists coming in and carry on. So it's about continuation, basically transfer from academic level to industrial level and into practice. And this is quite important, the partnership between university and industry.
When you said there's multiple universities looking, are you doing it in collaboration or are you doing it in isolation?
So there are certain things we do in collaboration because like we always saying, more hand and more brain, it makes things lighter, because then you can have people from different perspective and different testing. Because if you don't test from different perspective, you never found out. You're never going to find out whether it works. It might work for one condition, but it doesn't work other condition. And we're human. We're all different. And we want AI to replace the mundane, the day-to-day work, and that's so we can focus on a high value, the impact and the effective, and evolve to the future technology. We need to have multiple people to test the system, and that's what the collaboration and cooperation. The cooperation is the industry partner, the university partners, and then the young generation to be using the software.
I think with the universities, in my experience, so University of Queensland is where I went, they very much focused on the coal industry, and so over here in WA, it's more like underground metals, maybe potentially the iron ore industry, and so there's different learnings. But what I found was the general fundamental knowledge was quite similar. Do you think that's going to be applied across all of the degrees, or is this just going to be mining specific? Or
so every unit, every subject at university, we always look into AI, not just a course. We go down to the level of units, because each unit has some elements. So if you do everything AI and then so you have one missing piece, you don't worry about AI. That missing piece will be your bottleneck or your weakest link. So every unit that we teaching in university now, it has a component of AI in it. And therefore, every university we're doing exactly the same.
Does Curtin University or the government know how many roles are available or roles that we'll need available in the future, and how many people we need to get to fill those roles?
The answer, I don't know, and I don't think many people know at the moment.
That's probably a great statistic to know, right?
Yes.
So that we can, we always have this with the trade shortage. The government, they offer these rebates to businesses and to universities or whatever, or maybe not universities, but TAFEs. So, and they say, look, we need 10,000 sparkies, we need 15,000 fitters, we need boiler makers, we need this, and they go on a real big, huge drive and a big, huge push. Do we need to know some better statistics, better information for these university degrees? The other thing that I think, and this is just a personal opinion, do we need to start charging, this could be bloody controversial, and it's not what we're about here, but do we need to be reducing the costs of a university degree for Australian citizens and maybe raising the cost of the degree for international students? Maybe you can't answer that.
Like you say, it's very controversial. But the benefit of the Australian children and the permanent resident, they have access to the government fund COHEX. The overseas student already pay at a high price.
Yep.
And they're not just paying the...
I don't know what they're paying. I don't know.
So because they're coming here, they do not have... they don't have a home. They don't have accommodation.
Yep.
They don't have a job.
Yep.
So that's why they go to work. And all this is on top. Whereas Australian, they got the family and they already got, they easily for them to find job as well, and the money doesn't come out of their parent pocket immediately. We have a deferred payment, whereas the overseas student, they have to pay upfront.
Yep,
and if
that's gotta be hard.
And if you don't pay upfront, it's quite expensive. So look, they already pay, and on top of that, the living standard. When you live alone, you're still paying $400 to $500 a week of rental. And you look at that, that's the cost of accommodation. Then you look into food, internet, traveling, and so on. It's add up. So a few years ago, I'm not talking about a current statistic because it's not nice. A few years ago, to do a accounting degree as a overseas student, it costs roughly about $75,000 a year per student.
What does it cost for an Australian citizen?
I would say about 25.
Okay. Okay.
Yes. So that is the cost.
It's huge.
It's
okay.
They pay a lot to be here.
I was unaware. I didn't know. I'm glad you were able to answer that. So, what about industry? Could we be looking at
scholarships or something like that?
From some of these mining companies, if you want to have the skills that you want.
Yeah, there's definitely scholarships available. The issue's always been attraction, right? So we had endless amounts of scholarships we could apply for when I was going through university. It's just we didn't have the people. So I think the real challenge for the university is attracting people to the degree in the first place, specifically for the mining subjects, because they're just not well known.
I think an issue in Western Australia, and I've heard it, boots on the ground, is why go to university? So 17, 18-year-olds they're coming into a trade. I hear this quite often. Why should I go to university? And I can see you guys nodding. You know where this is going. Why should I go to university and pick up a $120,000 debt over 4 years while having to struggle to pay for the ridiculous cost of living? And then when I can, as an 18-year-old, go and drive a truck in the mines or go and work and do anything in the mines, starting at $120,000 a year.
And that is a very good approach of what reality in the last 1.5 decades in Australia.
Yep.
The last 15, 20 years, that is the environment we have been harvesting. We allow this happen. And the student, certainly in year 8, they say, well, why should I doing science subject? My mum, my dad never went to university and they earn $140,000 a year and they still living comfortably. Therefore, I believe that I should be okay.
Well, they're not okay. No one's okay.
And that was the culture that we've been living on. But that was then. What we need to do now is proactively, from all angles, And that through this podcast and through event that all Startup M been organized on a monthly basis. And Curtin University, we have student opening day and all the events that we create. Every organization, institution, association doing this, it's about communication to the right people at the right level and raise awareness in the effective way, not just background noise. The communication we have done in the past is become a background. So what we do is showing things to them. This item here you use, can you live without it for a year? If they say no, so what do we need to do? Make sure that it doesn't go away.
Yep.
And that's coming from very, very young level. And they say, okay, if you want to do this, you got to go somewhere when you turn 16 to 18. And they need you to have this basic knowledge in order for you to do that, because it becomes difficult for you to comprehend because you haven't put your head learning this subject to help you to understand it. For example, if you want to do an engineer, you need to do very complex math, like math specialists. You need to do chemistry. You need to do physics. They are very technical and very hard for the student if they don't think ahead in year 6 and year 5 to start understand the basic math, because it's a building block. And basically, you just allow students just to do art and reading geography and so on. You're not able to do engineering because it requires a lot of calculation, chemistry and physics. Physics is understand the physical activity, and chemistry is a chemical reaction and so on. If you don't understand those basic, university will not put the risk on you. You're going to spend 4 to 5 years in the university, and your mind's totally blank, and you wasted. And that is why a lot of students, when they graduate in the past, they don't get a job because they still do not get the concept. Yeah. So that concept needs to come back to all the way to primary school when we teach basic science. And
did you notice that, Andrew? Did
Yeah,
you notice that
yeah, definitely.
at university that once you finished, there were lots of people that just didn't end up with a job because they didn't quite grasp it?
Yeah, and you see, so there's, I think from our degree, I think it was like 80% of the people that signed up initially had dropped out by the end of it, and then there's after that another probably 50% dropped out of the industry entirely because they just didn't like what they were doing. So, or some of them didn't get jobs and had to reskill into other industries. So yeah, it's definitely a thing. It's one of those things that people start a degree and then they sort of feel like they're committed as well. So they get 4 years down the garden path and then they go, well, I've wasted all this time and money now, so I may as well do it. And then they get in there and they just hate it. Yeah. And particularly, like the mining industry is a tough industry to work in. You're working away from home and your family, and it's just not for people sometimes.
Yeah, sometimes.
I just want to redirect the conversation a little bit. You've got some show and tell here, but talking about critical minerals in Australia as well, just understand what the future of that looks like.
Yeah, so critical mineral, it's the only reason it's critical because we're not able to produce it globally. We rely on 1 or 2 countries able to produce this, and that's the key word is critical. The minerals around the world is abundant. It's just how to explore it, and mine it, and then treat it and refine it and put it into the product. Not many countries have been doing that in the last 2 decades, and that's where it's critical. Australia, we have endowment of rich minerals, and we got nickel, cobalt, rare earth, iron ore, and so many others like PGE. Now, recently we do a lot of PGE in there. We've got platinum, palladium, rhodium. Those are the minerals that using in high tech. And then in the last 6 months, gallium and germanium becomes important critical material. It all goes back. When you have an operation, you invest $1 billion, and you only have 1 or 2 people know how to do it. It's the highest risk. If that person drop dead tomorrow, who's going to run this plant?
So you think the critical risk in terms of getting these operations up and running is around the processing, or is it?
Absolutely.
So it's not the abundance of the resource
Correct,
itself.
correct. So, to get the process from A to B, no matter how where the process, after you digging, crushing, sorting, that's easy bit. Everybody can do that, but it's still training. But it's easy bit of it. Then how you going to remove the burden material and just treat the concentrate? Because think that we no longer have the same minerals concentration that we had 20 years ago. Now we're dealing with gold. We're talking about 0.5 gram per ton. Now we're dealing with rare earth. We used to have 10, 20,000 gram per ton. Now we're dealing with 5,000 gram per ton. PGE, we used to have 50 to 100 gram per ton PGE. Now we're dealing with 10, 20 gram of PGE in the ore. Nickel, we used to do, when I first started my career in the 80s, we're looking in between 3 to 4% of nickel in the ore. Now we mine the ore, the sulfide ore is roughly about 0.2 to 0.3%.
Wow, that's wild.
And this is why the process required to do it, we have to shift our way of thinking and how we extracted this in the very sustainable way and economic way, because the whole reason you're doing this because make money.
Yep.
The industry won't exist if it doesn't make money. And then you have to comply the regulation that we have in Australia. It had to be environmental compliance, and it has to meet all the standards.
Do we need more smaller pilot plants to process this? What are we going to do about it?
Absolutely, Josh. You need, in order for us to skill up people, we need to have more small plant rather than mega plant. It's small capital, and then the impact is quite small because the oil you generate to put in and the waste, potentially waste, is small. And then you put the people through the training, so if they do make a mistake, it doesn't cost tens of $millions. The current scale of plant, when you make a mistake, the plant goes down, it costs tens of $millions.
Look, imagine Linus in Kalgoorlie going down for, well, they obviously have planned shuts and whatnot, but imagine if there was a mistake in that process.
That's right. And that is why, in order for us to de-risk it, it's able to put these training process people, and no one want to put training people in a $1 billion plant in the mess. They only put, if you got enough skill to understand to running it, minimum 10 to 15 years skill of this in order for you to put in this role. But they haven't really actually been through a small plant to see the intricate component of it. So that's why, leading to Curtin University, we work with future battery industry in the last 4 years, and we built a pilot plant there. It's to treat Australian battery material coming out from nickel west and cobalt and manganese coming from potential operation that eventually put into operation. And then we're producing this chemical. At the moment, most of the operation, they're producing intermediate product like MHP or MSP. Only Maramarun and Kwinana nickel, we're producing the metal powder into a briquette, and we export that. So a few years ago, when BHP started producing nickel sulfate to supply to Tesla and Toyota and other battery manufacturing around the world outside of China, they still have to purify it, and then once the purity of nickel is met the requirement, it's still in a liquid form. The liquid form need to form into a solid because transportation costs. When you get something down to 99.9% purity, it's a lot of process steps to get there. So you don't want anything happen to the solid when you package it, store it, transport it, unpack it, and reprocess it. So that's why the future battery industry was formed in 2019, is to look into how we can embrace the technology that outside of Australia is to further integrated downstream processing to producing precursor for the battery material. So one of the 15 projects that was granted and with participants, so it's $125 million fund in total, and with over 75 participants, and all the university institutions and partners from like BHP, IGO, Rio Tinto, all the big mining company involved and small mining company, and then also engineering houses and also suppliers. So I was very fortunate to involve initially as a partner, participation in this project. So we put in a certain amount of money to ensure this project get fund. And eventually I got involved and then took over and lead the team to ensure this pilot plant. So this pilot plant taking the solution, not the solid, and then we generate a feedstock, not at liters, with hundreds of liters as a feedstock, every single chemistry, and we put into a high engineered state-of-the-art precursor production pilot. So we generate the precursor, and you can see the green color there is represent nickel sulfate, and then you got the light pink there, that's manganese sulfate, and then you got the red / orange, that's cobalt sulfate, and that's the material that all the factory NCM or MMC factory purchase to producing NCM cathode material. So this material can be acquired through downstream integrated process from our operation in Australia into a precursor production plant. And then you just adding that in the chemical, like a little bit of ammonia and then caustic. So caustic is a product from seawater, the salt. When you put the seawater into the pond, you dry, you produce the salt, you wash the salt, you redissolve that, and then you put into electrolysis, and it split the sodium and chloride and produce chlorine gas and sodium hydroxide. Wow. But to transport the sodium hydroxide around the world, they need to evaporate the water as well. So that's energy. So to producing nickel, cobalt, manganese solution in the process, but to transport this product, you have to evaporate. So most of the solutions contained in there is about 75%. So you have to get all the content of 75% with water, and because they are salt, it's not 100 degrees. It's got to be 150 to 180 degrees, and that's a lot of energy. So when you want to remove 1 ton of water, you're talking about between $20 to $30. It depends the price of your energy, the gas or the electricity. Between $20 to $30 cost just the energy consumed to boil up the water. Then after that, you have to cool it in order for you able to package it. And then the packaging has to be multi-layers protected. So all these, the cost is accumulating. And then when you transport this, the company that about to reprocess this, put that back into solution, the water got to be ultra pure. Yep. It's not no more drinking water, sea water, or potable water. You have to put out a lot of filter to have 99.95% is pure water. And that process requires energy and processing. Then you redissolve this again back to the concentration that we produce here. So that is the advantage of cost.
It's a lot of waste.
Cost,
isn't it?
yes, and cost improvement for Australia to do it in Australia is that cost. The transportation, the energy that you no longer require, and the pure water you need to redissolve, and then the packages you put into 4 layers of plastic bulky bag. What do you do with that? So you eliminate the waste of the plastic and the package. You have to store this in a very nice, cool environment. Otherwise, they form into lumps, and everything is hygiene. So if you put a fully vertical integrated plant next to it, and you producing the final product is the precursor of the material into the lithium battery before we're adding lithium to it to lithiate it. That product there, you don't need to reprocess anymore. So instead of sending that 4 or 5 product there in liquid, but you have to convert to solid because of transportation, you have to eliminate that process. That's multiple process step. and equipment that you have eliminated out of the process, and therefore that's a capital reduction.
So what sort of reduction are you talking about in capital?
Depend where you are. It depends where you are.
Yeah.
Depends on the size of the pilot plant.
Yeah.
It'll depend
Yeah.
on so
the
many
size of the
different...
plant. Yes, correct. And also the automation side of it. The more automation, the more expensive, and so on.
Yeah.
We're looking between 20 to 30% reduction.
Yeah, because it's interesting because when you talk about the project economics, you go, usually people are targeting scale, right? So they want a larger resource, they want to get higher throughput rates so they can get the economy of scale effect. So when you're talking about reducing the size of the plant, obviously bringing capital down is really good for your NPV values. But then also, presumably, you're reducing your throughput rates and everything as well. So smaller equipment, so that further reduces capital. But yeah, it's really going to be, I think your big value lever is going to be the price of your commodity itself.
Yes.
Whether or not the project's
But
going.
you can always start with a smaller pilot plant and leverage off that to build a mid-sized
you
pilot
can.
plant.
But if you're still talking about hundreds of millions of dollars of investment,
huge.
it's
wild.
it's a massive difference.
The benefit of that is training the people.
Yep.
Because people is the highest asset for any process operation. Even instrumentation can replace a lot of things.
But you need bloody good instrumentation sparkies, and that's like a
Absolutely.
2-day course. If you're an electrician, now I think it's not. It's a 2-week course. It used to be a 4-year course, a 4-year trade to do your instrumentation. But obviously we're a throwaway society now, so having to calibrate level, flow, it's just not there anymore. You just go to Vega, you buy some new stuff in and put that in. But you still need to educate those people.
Absolutely, because every instrument coming in, they have their parameters, how you build it into the system. You can't just plug and play. You got to reconfiguring it because everything coming in is a standard, for electronic like 0 to 20 millivolts, right? You have to calibrate at what millivolt is the reading that you need, right? So in digital, whether it's fiber optic or copper wiring and so on, these transmission need to be compatible. You can't just plug and play, and the equipment that you installed 2 years ago might not be in production, and in 2 years later, you have to changing that material. And this need to be trained to this instrument and control engineer to be able to bridging that gaps. You have to have adapters, or you have to changing your infrastructure to be able to accommodate this. More and more in the future, you're never going to see wiring anymore. They will be all wireless.
I hope not, because I still need to be working.
You still have the wiring, but not for every single thing that we're doing now. The wiring is the framework that's a solid that you need hardwire. But little instrument here and there,
Yep.
you need
It's
to...
already there.
Yeah.
Bluetooth capability,
Yes.
wireless capability, it's already there.
Yes, and it's very important, and then you can see there, and that's one of the things that we able to do at Curtin and with the partner with CSRO and all our partners. We had 23 partners. The initial process, it would take roughly about 20 to 25 hours to produce a product. During the campaign, during the improvement and process, we can reduce the time to produce this product significantly. We now can produce this product around about 2 hours instead of 25 hours.
Wow.
So you can have the plant size, right? And we're talking about
Time is money.
No, the plant size. Let's say you're producing a ton in the past. Now you can produce 10 tons of the same size of plant. And that is coming down innovation and stability of the team, and you put people in the place that they understand what needs to be done. Every day we're challenging our team. And so now this team we have at Curtin and CSRO, there are 30 of us, right? And we continue to get the support from WA government, sort of the Institute of Research of Western Australia, Mirawa. They continue to fund, to maintain, to keep these technical people and continue to doing research how we can improve our productivity, improve our chemistry, improve the material for the battery. So we continue to fund this. So this operation is actually currently live at Curtin University with CSRO.
That's awesome to hear. So it looks like the future's bright.
The future is there, but we still need more people going through it.
Yeah.
Yep.
To have this battery plant in Kwinana or in Kalgoorlie or anywhere in Australia, we still need roughly about 100 to 200 people who actually know, because the more they know, the faster the operation. When you hear operation, complex chemical plant, you hear the commissioning is taking years. But if you have a lot of people, everybody know where the area, you're not being stretched too thin, the commissioning phase is getting really short, right? And also the operation start kicking in, the ramp up is much quicker. I remember when I was at Miramar, and it took us between the end of 1998 and by August 1999, we already have the plant up and running. And I remember Andrew Forrest came on site, and he could not wait to go to the autoclave. When we're producing the first discharge, he just put the sample there, and he just take the sample and straight to the lab and say, analyze it, I want to see. Awesome. So he was very involved, but we have engineers come from Canada that at the time called Dynatech, right? And we got all the engineers around the world focused to get Miramar up and running, right? And we got people here been running the pilot plant in Perth, Strand, myself included. So you have people who've been running this process. We're not afraid of running it. And we have so much practice. So same thing here. If you want to producing battery in Australia, we need more people get involved and practicing. And, in this plant, we have a control. Every unit we operate is fully controlled. And then teaching the control room operator how you're handling the material, what are the category requirement to run it successfully, like automation, how you adjusting automation. The plant that we have there, so most of the plant preparation area is still manual, but when it comes to make precursor, it's fully autonomous. No human, we can run that continuously, 24/7, and this plant, we run continuously for 15 months production. And it's not a few days and then you stop. We actually, production, we're producing 1.5 ton of different chemistry of battery grade product.
Wow, it's fascinating, Tony. We could talk about this all day. I think we probably need to sum it up though and get some closing remarks. Is there anything you want to, say to the audience?
Yeah. What would be the biggest takeaway? Last question. Look at the camera. Tell whatever you think the biggest takeaway for the audience.
For me, it's about the people, and the earlier we get involved, the children to understand and appreciate how important their future and their life is. Get involved and get into the right study field, and hopefully take these challenges and provide a solution. It's all come down to our people, and it starts from as early as primary school. And then we involve people in industry, the government, and also collaboration, international people sharing that knowledge, because no point, if we want to solve the world climate situation and critical condition that we're in, especially critical mineral and critical material, we have to work together. We can't just work in a silo. And with that partnership, with that openness and prepare to work with each other, then we must see the word critical
Would just be minerals.
critical word disappear.
That'd be nice.
Yes.
Minerals, that's what we're mining.
Yes.
Beautiful. Well, Tony, mate, thank you very much for coming in and spending the time with us. You are a wealth of knowledge. I know I could sit there and talk to you for absolute hours. Andrew's much the same. So once again, mate, thank you very much.
Thank you, Andrew. Thank you, Josh.
Appreciate it.
Yes.
Mate, thanks very much for coming in and spending the time with us. We'll get you back, do another bloody co-hosting episode, so thank you.
Brilliant. No, love it.
Thanks very much for tuning in to another episode of The Gold Room. Two absolute legends joined me today. I hope you enjoyed the episode. If you did, throw some comments down. That would be fantastic. Cheers, guys. Thank you.